Before we begin with our question 5, as usual, we will write our rules that we need to follow in solving that problem. The interpretation, classification, answer, and navigation of the answer that we get. Question 5 says that a light inextensible wire is used to pull a crate with a force of 400 newtons. The surface exerts a friction force of 200 newton on the 80 kilogram block as it moves to the west. So this is question 5. I'm going to quickly draw the scenario of the crate so that we are able to interpret this problem. They say to you that the crate moves to the west. That means it has an acceleration that goes to the west. So here it looks to me that we are using the cardinal direction, right? And in this case, I'll say west is positive and north is also positive. That's how I'll choose my direction. So the force that is applied on this object should go to the west because it's the one that is, attempts to move the object in that direction, and the friction would go in that direction because it's trying to, this is kinetic friction. When we're saying it's going to be 200 newton, it's trying to oppose this motion that we are generating with this force of 400 newtons. This box has a mass of 80 kilogram. Yes, and that's what we have in there. Again, when you look at this problem, if you classify it falls under Newton's laws of motion because I can see acceleration and the forces acting on object giving me the net force in there. So the usual questions that we've been getting here, we will expect them to come through. I think at this stage you start to gain experience with these problems, and they're becoming more simple now. So we'll go to answer the question now and go to 5.1, where they require us to draw a free body diagram. Drawing a free body diagram, the quick two forces that I see is the force F that are on my force diagram there. This is kinetic friction. And the other force that I know is that the surface will push this object with a force Fn, and the earth will also pull this object with a force Fj. So that's where the 4 marks will come for each arrow there. Now 5.2, they say what type of friction does the surface exert on the crate? I mean, already we said this friction here has to be kinetic friction, right? Because the object is moving, right? So the type of friction here is kinetic frictional force. Sometimes you can call this dynamic frictional force is one thing. Now on 5.3, they say calculate the net force acting on an object. 5.31. So to get the net force acting on this object, obviously the net force is in the x direction. If you are able to see that the net force is here in the y direction, in this direction, there is no net force. The net force is 0. So they're not referring to the y component, because when I add these two forces, they must give me 0, since the object does not move up or down. It has no acceleration. It only has this acceleration here, right? So this question refers to the net force here because it's the one that causes the acceleration here. To get the net force, we're going to use our definition of the net force from lesson 1 of Newton's laws in our series of lessons, where we said the net force is equals to the vector sum of all the forces acting on an object. So this means I'm going to add these two forces that I have here. So this means that I will say Fk, the kinetic frictional force, plus minus, right? You know, here we're going to have a plus minus F, right? The reason being is because this force goes to the positive direction to the east, and this one goes to the negative direction to the west. And so this means now here that I will have the kinetic friction to be 200 minus the 400, because positive and negative gives me that. So here I will get an answer that says negative 200 newtons, right? So this means that my net force is equals to 200 newtons to the west. Does this make sense? Let's navigate this answer, right? We are on navigate. Now, navigating this answer, you would see that we expect the net force to go to the west. You know, we expect our net force to go to the west. Why? Because remember, according to Newton's second law, the net force and the acceleration are directly proportional, meaning they go to the same direction. So if we say this object accelerates in this negative direction, the net force also should go in that direction, right? So I have my SI unit, I have that, the answer, which looks good, and also that. Another way to navigate this problem would be you changing the direction. Choose the direction in a vice versa way. Choose this as negative and make this positive and see what answer you get. You should get the same answer but with a different direction, you know. Another way to go around this problem, maybe you can increase some of these forces or decrease them and see how these behave, right? Remember, when you increase any of this, we expect this to also increase, right? Now the last question says calculate the acceleration of the crate. Now, to get the acceleration, I'm going to use Newton's second law, where I come and say we know that the net force is negative 200 Newton and this object is 80 kg multiplied by the acceleration that we're looking for. I'm going to divide by 80 on both sides so that the 80 cancels and I am left with A, which gives me 200 divided by 80. 200 divided by 200 divided by 80. This gives me 2.5 meters per second squared. Remember, there's a negative there, right? Because we're having a negative 200. Now, this would mean that our acceleration is 2.5 meters per second squared to the west. We expected this to be the west. Even in our diagram here, we have drawn our vector without calculating it because they told us this object moves in that direction. And now the answer confirms that to say it's going to the west and is about 2.5 meters per second. The correct SI units are there, right? We'll go to question C.